Hi everyone, my name is Tyler Fedrizi. I'm the CEO and co-founder of Codex Labs. Today I'm going to talk to you, give you a 5-minute demonstration of the Swarm simulation platform. So bottom line up front, what is the Swarm simulation platform? We developed an integrated, fully featured development tool. Right? We have a full development system for simulating, testing, and deploying single or multi-agent autonomous robotic systems. Now, this is not just a simulator. We do have a very simple, easy-to-use interface. We have photorealistic environments. We use Unreal Engine 5 to make that happen, but it's also a development and deployment system as well. We have integrated sensors, vehicle types, and more, and we also have a really easy and extensible system underlying all of this that allows you to build and test algorithms and deploy those with ease. We do most of our integration with Docker, so this is a very flexible, very scalable solution. Now, I said the word cloud-based, but really that could mean your cloud on premises, that could mean on your local computer, that could mean in AWS, Azure, really the options are unlimited. And a big question we get as well is this platform secure, right? We use cybersecurity best practices from the start. We have virtual private clouds, virtual private networks. We use SSL encryption for nearly all of our processes to make sure that this system is safe and secure for you. Now, we have an automated testing platform, right? But part of that platform, we have a web-based solution at swarmsim.io where we're developing marketplaces. We have forums, we have different knowledge bases that you can utilize so that you can build and develop your systems super easy. But we also have very high fidelity environments, and that's what you can see in the picture in the bottom right. That's kind of what I'll give you in the demo today, right? We have photorealistic Unreal Engine 5 environments. We have custom lighting. We have a lot of different features that allow this system to be as flexible and easy to use as possible. Now, the name of the platform is Swarm, so you might think, well, multi-agent, multi-vehicle. And that's exactly what we're working on. Right now, we have the ability to simulate multiple UAVs, but in the future, we're working on fixed-wing aircraft, vertical takeoff and landing, ground robots, and the ability to simulate all of those together using our Python-based easy-to-use framework. Now, you might ask, what exactly does this platform look like? So this is actually my VS Code development environment, and this is the platform itself. Right, this is a public open source client that you can download. You can integrate this into your products or your services. You can utilize this for a number of different applications. This simulations file that you see here, this is your command center. This is the only file that you have to interact with to actually be able to use the system other than writing your own algorithms. Today I have a really simple 2-drone example, and I have a nice A-star algorithm that I've written here in Python that allows you to kind of just see a good example of the system. Now, right, there's a number of different features and options here. You can say whether you want to collect video data or image data, potentially if you're doing machine learning. You have your scenarios such as navigation. Our navigation scenario is just given a goal point for each agent, have that agent achieve that goal using some type of planning algorithm. Each of our agents, though, is really flexible, right? So you can see here I have drone 1. If I want to have drone 2, I simply just make another structure, really just copy it over. Is usually what I do. And then I have a ton of options for each agent. Now, each agent in the environment is made up of a number of what I call software modules or software nodes. And really think about it the same way you think about ROS, right? It's a set of nodes that you generate. They all do different features. But we do all of this in Python. And we use multiprocessing so that we can guarantee concurrency, but we make it as efficient as possible. So, kind of what you'll see here, this is our mapping module. It's building out an automated occupancy map that is provided to the planner so the planner can make kind of informed decisions. But this is a very flexible algorithm, and this is already provided for you, right? So our algorithm we have is an occupancy map generator, and this is a tool built into the system. We have the algorithm that we're actually building and testing. We're just using a nice A-star implementation. And what you'll see here, it operates a lot like ROS, right? We're going to publish a trajectory. I'm subscribing to the state of the agent, subscribing to this nice occupancy map. Publish and subscribes work kind of the same way, except you have to do no work to make that happen. You don't have to worry about callbacks or threads or processes. All that's handled for you. You just have to list here, hey, here's the data type I want to listen to, and you'll get that. You'll be able to listen to that data type. So what's really nice about this system is that you can have multiple agents defined, and they can be completely different. So if you wanted to use A-star for one or RRT star for the other, that's a really simple and easy to use process. Now, for the A-star algorithm itself, the only thing you have to do is inherit from the algorithm class. We provide a number of utilities that are available that allow you to really quickly and really easily generate an algorithm and make it possible. We also have a set of custom data structures that, again, we provide to you as well that make sending data really, really easy, and we're working on being able to allow you to extend those data classes automatically. Now, the only real requirements here for your algorithm is just this run function. You have to accept some keyword arguments so that you can receive the right data type. And then other than that, it's totally up to you. Whatever you want to do, basically between calling the run function and returning, that's all up to you. And that's really the only code that you have to write to make this happen. So now that I'm ready to go, now that I have my entire system set up, I want to actually be able to run this. Today, we're going to use Amazon Web Services. However, you could use this in, again, you could use this in Azure, you could use this kind of wherever you wanted. I have the IP address of the server, which is the only real piece of information that I need. We're going to use the traditional blocks environment. So I go ahead and run the system. It's going to ask me if I want to maybe build a new simulation settings file. I don't, because I already have one. I don't want to view a map of the environment. We're about to view the map. So it sends us off to the server. It actually does validation of your code to make sure it's actually going to run. It won't do any actual validity checks to say your algorithm is correct, but it makes sure that it will actually run in the system. And then from there, we kind of differ pretty far from your traditional system. So everything that we use uses a web browser to be able to actually see the environment, but it's still fully interactive. You can use the keyboard. It's really a lot like a video streaming video game to be able to make that happen. And so what you can see here is we have two different agents. If I zoom out far enough, we have two different agents going towards two different goals, running the same A-star planner algorithm, but I'm able to test in real time that this system works in multiple different cases for multiple agents. Now, what's really great about this system is it comes with all the features. I can view the output of I can view different output features of the cameras. I can have all of the different features that are available. There's a bunch of different camera angles as well that you can use. But underlying all of this, we're recording a lot of different data. We're recording the state of the agents, which I'll show in a second. We're also recording, you can also record video or images. So if you want to collect data for that and make it really easy to do machine learning tasks or synthetic data generation, that's also possible as well. So while this simulation runs, I won't take up all of your time watching an agent get to the end of the goal here. What you'll see, which makes it really nice, is that you just have the ability to control the simulation. So when I hit Control C, that actually goes ahead and ends the simulation, and then I'm able to download logs, right? And our logging system is really extensive. It's been built from the ground up over the years to be able to record the information that you care about. You can also, for example, with A-star, you can record your own information, right? And you kind of see that with this log message function. But again, a lot like Ross, you can automatically view that. But we create the log files for you, and we make these as orderly as possible. We also have an entire parsing system to make that happen. So, sort of today, kind of what you've seen an example of our Swarm developer system. We also have swarmsim.io, which is our website. Feel free, if you're interested, to contact either myself or Alex Zhang. And we are happy to kind of provide you with a more in-depth demo. We can ask any questions. We also build custom UE5 environments. We have we basically help our customers meet their needs for whatever you're trying to build. Thank you for taking the time to listen to this. Thank you.